Eventually I'll get this whole question out of my mouth. Okay, there we go. All right, so we have QRS. This is ventricular dipole and atrial repole, right? Look, I can see your faces now. If that's the case, then what does T have to be? What is left? Hang on, I can't hear you. Why can't I hear you? Okay, say something.
Ventricular.
Ah, there we go. Okay. Yeah, so ventricular repolarization or ventricular contraction, right? Okay. So basically what's going to happen is we go through this QRS complex, and by the time we get to the end of this, the atria are fully relaxed and the ventricles are just finishing up their contraction and they're starting to relax. So by the time I get to the end of the ventricular repolarization wave, everything from here all the way back to the next P wave is the period of time where everything in the heart is relaxed. Okay, you remember I told you guys in class that you can have atrial contraction and you can have ventricular contraction, but they can never contract at the same time. But they can all be relaxed at the same time. Okay? So if you think of an EKG, right? You've got QRS and then a T and then you've got a little space and then you've got another P wave and then another QRS wave, and they're connected, right? So this piece in here basically goes from the end of T all the way through to the beginning of the next P wave. And then we start all over again. Okay? Does that make sense? I know the first half of that was a hot mess, so if there's anything I need to go back and talk about again, let me know.
So that line right there, the last line is where the ventricles start to relax.
Hang on. Let me clear some of this off. Let's get rid of some of this. Okay. So ventricular repolarization starts here. Okay? This is the repolarization process. So by the time we get to the end of this, the ventricle has relaxed. Okay? So we've got relaxation here and we've got relaxation here. But the ventricles aren't the only things that are relaxed on that line. The atria are also relaxed there. That's important, and I keep stressing that for a reason. Okay, it's gonna come into play later. So are you guys sort of seeing how this connects with how the blood flows through the heart? Right? So when the atria are depolarizing, where are we in terms of where the blood is moving in the heart?
It's moving to the ventricles.
Yes, the blood is in the atria and they're moving into the ventricles. When we get to QRS, blood is moving from where to where?
From the ventricles to the semilunar valves.
From the ventricles through the semilunar valves out into the aorta and the pulmonary artery. So what is happening in terms of blood movement here?
Is it filling up the atrium?
Yes, the atria have to get full again, right? So you have this period during which everything in the heart is relaxed because the ventricles don't have any blood, they've already contracted, and the atria need to stay relaxed so that they can get as much blood into them as possible before they contract again. Does that make sense? I feel really sad. I no longer have Can you guys still like raise your hands or anything on here? Oh, there's a thumbs up. Oh, there's some thumbs ups happening over here.
Yeah, how are y'all doing?
Hey, look at that.
The reactions.
Yeah, so right next to share is a little
Yay.
smiley face with a plus, and that's where you
Oh,
put it.
yay. You guys need to use that. Those are making me happy. Those are actually much more entertaining than the other ones because they move and stuff. Oh, somebody's crying. Samuel, why are you crying? Why are you sad? There's no crying in A&P. Minerva, do you have a question? Or are you guys just playing at this point? All right, stop playing. All right. You guys are a riot. Okay. Any other questions about the EKG? We feeling pretty good about it?
So on the T wave, are we also, since there is the atria filling back up, do the ventricles also passively fill back up as well during that time too?
Yeah, well, yes and no. So we'll talk about that in more detail when we get to the cardiac cycle, which is sort of the next piece that we're going to add to this. Tyra, I think I saw that you had a question. Oh, look, there's your little hand up over there.
That's stupid, but
no such thing as a stupid question.
Is the plateau phase showing the EKG or not?
So the plateau phase is not something, is really what you're going to see happening sort of from here all the way through to here. Okay, it's not really something we look for. If you have, so when you're looking at an EKG, if you see lots of like T's really close to P's, like if there's less space between your P wave and your T wave, then that's an indication that you're getting contractions faster than normal. Does that make sense?
Yes.
Okay. Okay. All right. Any other questions here? Don't forget to put your hand down. So happy that we can do the same things in here. Okay. All right. Lakin, question.
So, will we ever have to like read an EKG without it labeled, like with the letters?
Maybe. But what I will tell you about the EKG in general is that it's, once you understand how it's laid out, and I'm not ever going to give you one where it's like one after the other, at least not to read information on. But the thing about an EKG is that when you work from left to right, the easiest thing to identify is almost always going to be the QRS complex. Okay? So the curve in front of, before the QRS complex is going to be your P wave. The curve after the QRS complex is going to be your T wave, because they go alphabetically, right? P, Q, R, S, T. Okay? I'm not going to tell you how long it took me to actually catch that when I was first studying this. I was a little slow on the uptake with that one. But that is, when I go to look at an EKG, that's what I look for, is I look for the QRS first, because that's the easiest to find unless you've got a really abnormal heart rate. Okay? The only time I'm going to give you an EKG to work with, it's going to be a small single version like this. Okay? What they do in the nursing program, I can't tell you about that. Okay. When it comes to changes in the EKGs, okay, nobody panic. You don't need to like be able to like explain to me what's happening in them, at least not in any great detail. They're the things that you need to know from this to be able to recognize these different EKGs, and they all look very different from one another. If you look at them all side by side, they all look very different from one another. You need to be able to identify which one is which, and you need to be able to tell me the information that is associated with each in terms of the bullet points that are on here. Okay? Beyond that, I don't expect you to be able to do anything with these. Okay, I'm literally, most of this is just so that you have some recognition. Now, slide and this slide, I will point out these two. And they both include the same word, fibrillation. Okay? Basically what we're talking about here is a quivering of either the atria or the ventricle. Okay? If it's the atria, it's really not critical, right? The contribution that the atria make in terms of the amount of blood that the atria contraction makes in terms of the amount of blood that's sent out to the body is minimal. And it is entirely possible that in older people, you may not even notice that there is an atrial fibrillation. Okay? Ventricular fibrillation, that's a bigger deal. That is something that will kill you. Okay? Because if your ventricles are not contracting properly, then what you're going to end up with is no blood getting out of the heart to the body. Okay? What do you know about that might relate to AFib and VFib? What is there something that you can almost always do if there's an AFib or a ventricular fib? Anybody heard of an AED? Or a defibrillator? A defibrillator is used to stop fibrillation. Okay? So when they talk about having shockable rhythms, there are some rhythms that you can use a defibrillator on and it will help. There are some that you cannot. Atrial fibrillation and ventricular fibrillation, you can. They're both shockable rhythms. Okay? All right. Any questions about these before we move on? I have you guys till 4:45, right? Yeah, okay. Okay, moving forward. All right. Cardiac cycle. Now, we're going to introduce two more words. So we've talked about repolarization, and the repolarization leads to what?
Relaxation.
Yes, relaxation. And then we've talked about depolarization, and depolarization leads to contraction. Good. Now, there are two other words that are associated with the idea of relaxation and contraction: systole and diastole. Okay? So diastole is the pressure measurement associated with the relaxation of a chamber. Did I say that right? Did I say diastole? I did say diastole, right? I don't remember now. So systole is associated with contraction of a chamber. Diastole is associated with relaxation of a chamber. So when you read a blood pressure, you're looking at systole over diastole. Okay? Less than 120/80 is good. Now, if you go into your doctor's office and you have a blood pressure that is, let's say, 140/82. And then on another day you go in and you have 125/95. Which one of these do you think is going to be the more concerning to your doctor?
The 140/82.
Why?
Because your heart is contracting more often than it should.
Well, this is not about how often. This is about the force of the contraction.
High blood pressure?
Well, so both of these could be considered high blood pressure because both of these have numbers that are above the norm, right? So the 140 over 82 is higher than 120 over 80. 125 over 95 is higher than 120 over 80. Both of them are concerning. But of the two that are the most concerning to your doctor, believe it or not, it would be this one. Why do you think that might be?
Is it maybe because
of relaxation? Is it because of relaxation?
It's related to relaxation. What is this 95 telling me?
That your heart is relaxed.
The other way.
No.
That your heart is not getting as much of a relaxation.
Oh,
Okay? The pressure associated with this number is higher than it should be, right? Which means that your heart is not getting that break in between contractions. This number can often be skewed by what they call white coat syndrome. Anybody heard of that? Anybody ever go to the doctor and you're not feeling great and you're a little nervous because you're afraid they're going to tell you something bad?
Oh, is that when you're like nervous so your heart rates up?
Yes, that's exactly what that is. That can have a huge impact on your systolic number. Okay? So they're both concerning. They're both something that the doctor would want to pay attention to. But the 125 over 95 is going to be significantly more concerning than a 140 over 82. Does that make sense? Yeah? Okay. All right. Moving forward. All right. Now, we're going to talk about the cardiac cycle. And there is a handout that I will send you instructions for on Blackboard. There's an assignment on Blackboard that I'm going to send you instructions for today. And you're going to want to do the handout before Thursday. It's going to be due before Thursday because we're going to talk about the actual answers to the handout in class on Thursday. And so I need for you to do the work before we actually have class on Thursday. So the cardiac cycle is basically talking about the changes in pressure that cause movement of blood through the heart. Okay? So we're going to start here and we're going to work our way around this cycle. Okay? And I've got this broken out. Hello. So we've gone from atrial systole and we've filled up our ventricles. And then we're now in ventricular, we're sort of in between ventricular diastole and ventricular systole. At the end of this step is when we get ventricular systole. And we still have ventricular systole here. It happens in 2 stages. Do you see that? Individual slides just because it's a little easier to see. So at the very beginning of the cardiac cycle, we have atrial systole and active ventricular filling. Okay. Now, this is going to sort of be the end. The name of this is sort of the end of this first step. Okay. So as we are looking at our EKG, right, so we've got our P wave and then QRS and then our T wave, okay? As we are looking sort of in this zone, okay, before the atria start to depolarize, there is a period of passive ventricular filling. And we'll talk about it again when we get to the end of this process. Okay? So normally, when you're just sort of sitting around, hanging out, doing your thing, and you're not exercising or, doing something crazy that's going to increase your heart rate, the atrial contraction is not necessary in order to fill up the ventricles enough. We will talk about, I just saw something pop up in the chat about the participation question, and we will talk about that at the end. So passive ventricular filling, basically it's just blood moving from the atria into the ventricles as a function of gravity, right? The AV valves are open because the pressure in the atria is greater than the pressure in the ventricles. Okay, so if you look at this heart, Lakin, you had a question?
In the passive, ventricular filling is happening like before the active?
Yes. Yeah. Yes. Yes. Why can I not figure out, what am I doing here? I have forgotten how to use, I am in this app. What am I doing? This is what you need, right here. Why are you not working? Hang on, something weird's happening here. Ah, there it is. That's what I need. All right. So if we look at this heart, okay? Hang on. There we go. If we look at this heart, these valves right here are open, okay? And because of gravity, because the blood is pooling in here, it's going to start to fall in here. Okay, these valves are open because the pressure in the atria, let's go with this. The pressure in here and the pressure in here is higher than the pressure in these two places. Okay, now that pressure is higher because the amount of blood in the... Somebody have a question? Lakin, do you still have a question, or did you forget to put your hand down? Sydney?
I forgot to put my hand down.
It's okay. Sydney?
So the AV valves are always open until the ventricles start contracting and shutting closed?
No, well, sort of. So, sort of. So, okay, so pressure. Have we talked about pressure at all this semester? And volume? Have we talked about this at all? I don't think we have, but if we have, I just want to know. Everybody's afraid to say no because they think I've forgotten or I'm going to yell at you. I don't think we have, but I'm just checking.
No, we haven't.
Okay, so I did sort of an ADH, but okay. So, pressure and volume. So if I have a container, okay, and it's a closed container, the amount of space that I have in here determines how much pressure is being generated, right? If I have this much blood, then that leaves me all of this space, which means that I'm going to have relatively low pressure. But if my blood starts to fill up this space and takes away all but this, that's going to cause the pressure in that chamber to go up. Okay? Think about this in terms of the pressure inside of a balloon, right? An empty balloon has very little pressure, but as you blow air into it or put water into it, it starts to fill and the pressure inside that balloon goes up. Does that make sense? Yes? Okay. So, yes, Caitlin. Sydney, don't forget to put your hand down.
The passive filling is when the blood is just like flowing into it, and then is active filling whenever like there has to be some kind of force making the blood like continue to flow in so it fills all the way up.
What kind of force would that be?
An action potential?
Well, yes, an action potential is going to cause it. What is the force associated with active filling? Contraction, right? Mm-hmm. The atria contracting, it's sort of like that last ditch to wring the last amount of water or blood out of the atria, right? If you're squeezing a sponge, right? That squeezing of that sponge is going to force more water out. The squeezing of the atria, that contraction, is going to force the rest of the blood out, okay? But the reason that the AV valves are open is because the pressure inside of the atria has gone up because the volume of empty space has gone down. Okay, you have to think about the volume here, not in terms of the quantity of blood, but in terms of the amount of space in the chamber. Does that make sense? Is there anybody who doesn't understand that? This is a big concept that is going to play a huge role in your life for the next couple of systems. So if you don't understand what I'm talking about with pressure and volume, you need to speak up. Okay? So inside of the atria, inside of this space, we have filled it up. We've got all of this blood flowing in. And because we have all of this blood flowing in, we're going to create a pressure dynamic where the pressure in the atria, so the atrial pressure is going to go up, and it's going to be greater than the pressure in the ventricles, because the ventricles have very little blood in them at the moment. You'll note I didn't say none. I said very little. Right? Because we never really get rid of all of the blood. That doesn't happen. Does that make sense? Give me some thumbs up. Let me know you guys are hearing me and understanding me. I can only see like 6 of you at a time. There we go. All right. There we go. Let's make use of our thumbs ups. Okay. Moving forward. So we have gone through our process of passive filling, and we've also sort of gotten to the point where we're at the last of the process. We want to get as much blood out of the atria and into the ventricles as we can, because in just another second, the ventricles are going to want to start contracting. Okay? Somebody tell me what has happened in terms of the conduction system so far. By the time we get to the end of this part of the cycle, what has happened with the conduction system?
Is it ventricular contraction?
Well, okay, so go back to what I was talking to the very first couple of slides. The conduction system is when we have the SA node and it releases the signal, right? So up to this point, our SA node has released its signal. That signal has traveled through the atrial walls, right, causing depolarization. That depolarization is going to be what causes active ventricular filling to happen, because that depolarization is going to cause the atria to contract. So at this point, where is our action potential?
The AV node?
Yes, it's sitting in the AV node. It's waiting in the AV node because as soon as I release it from the AV node, the ventricles are going to want to start depolarizing. Well, are going to start depolarizing, which is going to change the pressure dynamic slightly. Okay? You guys with me? Okay. So now we move into the period of isovolumetric contraction. Now, let's talk about what this word means. What does iso mean?
Same.
The same. So iso volume. What does that mean?
The volume stays the
The
same.
volume stays the same. So anytime you see isovolumetric, doesn't matter what's after it, the first thing that you should think is, okay, at this point, blood cannot move. Because if blood is moving, then the volumes are changing. Okay? Isovolumetric means the blood volumes, the quantity of blood, I'm going to stop using volume because it will start to confuse you in a minute. The quantity of volume, or the quantity of blood in the ventricles and the quantity of blood in the atria at this point stay the same. They cannot change, which means that blood cannot move. Okay? So if blood cannot move, then that tells me that the doors that blood would go through all have to be what? Open or closed?
Closed.
Closed. They all have to be closed. So all of the valves at this point are closed. No entry, no exit. Nobody's getting in, nobody's getting out. Okay? The reason that they are all closed is because the pressure dynamics have changed. Okay? So now the pressure in the atria is lower than the ventricles. Okay? And because that pressure changed, those valves have closed. Okay? But we haven't gotten enough contraction or force in the ventricles yet to increase the pressure enough for the pressure to overcome the arterial pressure. Okay? Now, I want to be very clear about what I just said here. So you have aorta. I'm sorry. Whoops. That's not what I wanted. Where'd my eraser go? You have atria. You have ventricles. And then you have arteries. Okay? So your atria you have right and left. Your ventricles you have right and left. And your arteries are what?
Pulmonary and aortic.
Yes. Pulmonary and aortic. Okay? So there's two different pressure relationships we care about. We care about the relationship between the atria and the ventricles, and we care about the relationship between the ventricles and the arteries. Okay, so we have atria pressure less than ventricular pressure, and we have arterial pressure greater than ventricular pressure. So the pressure in the aorta and the pressure in the pulmonary artery is currently higher than the pressure in the ventricles. And because of that, the semilunar valves are closed. Do you guys see that? Yes, no, maybe. You have no idea what I'm talking about. Okay, any questions about what's happening here? No. Okay, now, there's a term in here that's really important. End diastolic volume. So somebody remind me, diastolic equals what?
Relaxation.
Relaxation. So the end, the end diastolic volume is going to be what is left at the end of relaxation in the heart. How much blood is in the, what, by the way, has been relaxing this whole time?
The atria.
Have the atria been relaxing this whole time? The atria just contracted, right? They squeezed. They completed their contraction. But the ventricles, up to this point, have been relaxed since the last QRS. Right? You guys with me? Okay, some of you. All right. So we're talking about diastole of the ventricles. Okay? We're talking about how much blood is in the ventricles from the last time the ventricle was in diastole, because we're getting ready to go into repolarization and systole. That's where we are in this process. So if we go back, Frida.
So if the ventricles are relaxed in this picture, how come the arrows are like pushing against the ventricles?
Okay, so the ventricles at the end of this stage will have started to contract. Okay? But it's going to be an isovolumetric contraction. So isometric meaning the muscle is going to tighten, but it's not going to tighten enough to actually squeeze. So it's just going to start building that, excuse me, it's just going to start building that pressure. Okay? The goal here is to increase the pressure in the ventricles enough that it will force those semilunar valves open. Does that make sense?
Yes, thank you.
Okay. Lakin, did you have a question?
The atria are relaxed though, right? It just doesn't matter.
Yes, we just don't care about them.
Okay.
What you will find is that we care very little about the atria most of the time. They're more of like a holding tank than they are of any real value. I mean, you know, they hold the blood. Sometimes they help move it a little faster, if that's all they really do. Okay? All right, so end diastolic volume, the amount of blood in the ventricles after active filling has completed. So at the end, right before we start contraction of the ventricle, how much blood do I have? That is your end diastolic volume, or your EDV. That is an important number that you want to remember. EDV is going to come into play later. Now, it's normally about 120 to 130 milliliters of blood. I do not expect you to remember that. If I ask you to do any calculations with that number, I will give you the numbers you need in order to do that. I'll give you the EDV and the ESV, and you'll be able to figure out everything else. But just understand what it is talking about. It's the amount of blood in the ventricle before the ventricles contract at the end of ventricular relaxation. Okay? How are we doing on time? Oh, we're over time. Okay. So here's what I'm going to do. You actually have gotten more information than my other class did. I am going to let you guys go right now. The thing that you're going to post for your participation question is the notes that you took at the beginning when I had you do the blood flow through the heart, and anything you added to that as we were going through this process. Because remember, I told you at the beginning of class, that's what I wanted you thinking about, was how those things connect. I want you to upload that information to the assignment, which I will create as soon as we get off of this meeting. I did not do that yet. I will send you, after we finish this meeting, instructions for an assignment related to a handout that